Good day, Grade 9s, and welcome to our WorksheetCloud Grade 9 Natural Sciences class. I am so delighted that you could join us today. Just a reminder, if you have a question during the lesson, send an email with your question to grade9@worksheetcloud.com. My name is Mrs. Ernston, and I am the WorksheetCloud Grade 9 Natural Sciences teacher. I am sure that you are ready for today's lesson, but please just check that you've got a pen and pencil to write with, some paper, and any notes or books that you think you may need. Today, we are going to be revising acids, bases, and having a look at the associated chemical reactions. We will revise the reaction of an acid with a base, and that this is called a neutralization reaction. When an acid, which is a pH 7, the pH of the resulting mixture will lie somewhere between that of an acid and a base. So even though the acid and the base will be neutralized, the resulting solution will not necessarily be neutral. And then we're going to have a look at some common laboratory acids like sulfuric acid, nitric acid, and hydrochloric acid. I would like you to have a look at the diagram up here. And I would like you to make a list of everything you can observe in this diagram. I don't think you need to spend more than about 2 minutes doing this activity. So why don't you pause the video now so that you can see the screen and make a list of everything you can observe in this diagram. Well, I'm sure you've created quite a list. So let's go through some of the aspects that I hope you were managed to observe. 1, you were able to see a penguin. You were able to see a pig. You were able to notice that there was a hat and that there were spectacles. Some of you might have said you could see a chemical reaction. You could see products, you could see reactants, you could see plus, and you could see an arrow. So let's just go through this for a moment. Those of you that said this represents a chemical reaction are correct. Here is our arrow that represents a chemical reaction. To the left of the arrow are our reactants, and to the right of the arrow are our products. Now, in this case, in our reactants, we have a penguin and a pig. The penguin has a hat and the pig has a spectacles. We have a chemical reaction. And then in our products, we still have a penguin and a pig, but now our penguin has the spectacles and our pig has the hat. So another good task for you to do is do a Venn diagram. So you draw 2 circles where they overlap with this intersecting piece here. And the one circle you label reactants and the other circle you label products. Now everything that is unique to the reactants you can write down in this part of the circle. Everything that is unique to the products you can write in this part of the circle. And where there are similarities, you can do this in the middle. So again, you may need to pause the video to complete this activity, and I don't want it to take you more than about 3 to 4 minutes. So we'll come back to looking at the reaction later on in the lesson, but for now, I would like to recap everything that you can remember about acids. So let's have a look at the picture. We have a lemon, an ant, some vinegar, a cool drink, a soda cool drink, a man putting chemicals into a pool, and a battery. So all these pictures represent acids. Now we never want you to taste any chemicals, particularly in laboratories. But those chemicals you are able to taste, like lemon, vinegar, and the soda cool drink have a sharp, sometimes sour taste. You do need to be very, very careful because some acids are able to burn you or corrode. So concentrated acids can be very dangerous. For example, when you're dealing with pool acid or battery acid. So you please need to be very, very careful when working with them. If we have a look at some common acids, here we have a table. And if you move on to the worksheet section with the worksheets associated with this video, I have asked you to complete this table. So if we have a look at our pH scale, it goes from 0 to 14. Acids we find at a pH of 0 to 6. Remember, neutral represents distilled water, and bases or alkali solutions go from 8 to 14. So you need to learn some common acids, and the ones that are important for grade 9 are hydrochloric acid, sulfuric or sulfurous acid, and nitric acid. You also need to learn the formula of each of those acids. Now these are acids that we'll be working with in the laboratory when you carry out experiments, and these are all examples of a strong acid. So when we have a look at this table, what do we mean by a strong acid, a medium acid, and a weak acid? Well, acids vary in pH from 0 through to 6. So a strong acid would be pH 1, a medium acid 3, and a weak acid 5 or 6. Just to remember, acids are very corrosive, and even when they have been diluted with water, they must still be handled with extreme care. It is also important for grade 9 that you do learn the different uses of acids and where we find them. So we can find hydrochloric acid in your stomach, and we also use hydrochloric acid in swimming pools. Sulfuric acid we find in car batteries. Nitric acid we find in fertilizers or explosives. Phosphoric acid is used for rust removers. Carbonic acid you find in your soda cool drinks. Acetic acid is just a scientific name for vinegar. Formic acid is what you find in ants and nettles, and that's why you get that burning sensation when you step on a stinging nettle or get bitten by an ant. And then citric acid we find in lemons, oranges, and other citrus type of fruits. A little bit later on in this lesson, we're going to be having a look at carbonic acid. Then some general knowledge about bases. So bases are chemicals that are opposite to acids. They react with acids to form water and a chemical called salts. By the salt, we don't necessarily mean sodium chloride. It is the salt based on the acid and the base that are reacting. Bases can have quite a harsh, bitter taste. If they are in solution, the alkali solution can feel quite soapy. Bases can also dissolve in water, and when they do, we call them alkali. A concentrated alkali solution can burn the skin quite badly. So some bases you may have come across is baking powder, antacid tablets, things like Enos and Gaviscon that you will take when you have indigestion or heartburn, Clorox, which is like Jik, cleaning agents. You might have come across bases in forms of soap, hand soap, bath soap, and we can also find bases in a fertilizer, particularly fertilizers made up of bone meal. So it is important that you learn this table where you look at the common bases that we will find in a laboratory it is important you learn the formula of these bases and particularly where it is used. So sodium hydroxide or caustic soda is also used as a drain cleaner and in industries. Calcium hydroxide, we find that in fertilizers and we use that to neutralize soil acidity. Magnesium oxide, you might find that in things like milk of magnesia or Rennie's tablets or Gaviscon. Calcium carbonate is also found in fertilizers and we use it to neutralize acidified lakes or acidic soil. You might come across sodium hydrogen bicarbonate before. This is known as bicarbonate of soda or baking powder. And that can be used as antacid in medicines, and baking powder has all sorts of different uses. And then ammonia, you also have to be careful of because it is very toxic and you mustn't breathe it in. But that can be used in the home as a cleaning agent. But again, please be very careful. So the common base that is generally used in the science lab is sodium hydroxide, which is NaOH. Just a reminder of the pH scale. That is a scale from 1 to 14. pH of 7 is neutral. pHs 1 to 6 is acidic. And pHs 8 to 14 is basic or alkaline. A strong acid will have a very low pH. A strong base will have a very high pH. If you are neutral, you are pH 7. A very weak base will be pH 8 or 9, and a very weak acid will be pH 5 or 6. So the pH scale is a measure of the acidity or basicity. On the pH scale, acids have a pH less than 7, neutral substances like water have a pH of 7, and bases have a pH greater than 7. The stronger an acid, the lower its pH. The stronger the base, the higher its pH. So acid-base reactions always produce water and a salt. And this is known as a neutralization reaction. When an acid and a base are mixed in the right amounts, they will neutralize each other. That means that together they will change into something that is neither an acid nor a base. So the acid will lose its acidity and the base will lose its basicity. So we have learned that acids and bases neutralize each other. So if we add a base to an acid, the pH of the resulting solution will increase because the acid will lose some of its potency. It does not mean that the resulting solution is always necessarily neutral or pH 7. And we have also learned that acids and bases neutralize each other. So if we add an acid to a base, the opposite will happen. The pH will decrease because the base will lose some of its potency. And again, it does not mean that if we add an acid to a base, we'll end up getting a neutral pH. Let's go back to this diagram with our penguins and our top hats and our pigs and our spectacles. Let's assume that A is the penguin and the hat will be B. C is the pig and the spectacles are D. So the penguin and the hat and the pig and the spectacles are our reactants. And they undergo a reaction. And in our products, we'll end up having a penguin with spectacles and a pig with a top hat. So A and B and C and D are our reactants, and they are undergoing an exchange reaction. So they are exchanging, so the penguin exchanges the hat for the spectacles, and the pig exchanges the spectacles for the hat. So A plus B, so A and B are reacting with C and D. They undergo an exchange reaction, and A bonds with D and C bonds with B. If we link this up with a neutralization reaction, we can get an acid plus a base gives us a salt and water. So if we take an acid being HCl, a base being NaOH, get a reaction, that means we land up swapping. A stays the same, so A in this reaction represents the hydrogen, B represents the chlorine, C represents the sodium, D represents the hydroxide. So when we react it together, A stays, but it swaps the OH for the Cl. And then C is our sodium, H is our hydroxide, sodium stays the same, but it swaps the chlorine, which is B. So we don't write it as HOH, we write HOH together as water. So acid plus a base gives us water and sodium chloride. So acid plus a base gives us a water plus a salt. So in this reaction, can you see that we have exchanged compounds and elements? So hydrochloric acid, which is HCl, plus sodium hydroxide, which is NaOH, undergoes a chemical reaction and makes sodium chloride and water. So hydrochloric acid plus sodium hydroxide gives us sodium chloride and water. The acid gave its H towards making a water molecule. The base gave its OH towards making a water molecule. And the Na from the base and the Cl from the acid combined to form a salt. So our acid plus a base made salt plus water. So non-metal oxides form acidic solutions when they are dissolved in water. Metal oxides, metal hydroxides, and metal carbonates all form basic solutions when they are dissolved in water. Can you name a few non-metal oxides and write down their formula? So if we have a look at the periodic table, let's start by finding oxygen. So there's oxygen, and we are going to look at some non-metal oxides. So we'll look at carbon, and we will look at sulfur. So we have looked at two examples of non-metals reacting with oxygen to form non-metal oxides. Both of our examples had dioxide as a product. So for example, carbon dioxide and sulfur dioxide. So here we have carbon reacting with oxygen to form carbon dioxide. Carbon is the orange circle, oxygen is the blue circle. So one atom of carbon reacts with two atoms of oxygen. There's the reaction to produce one molecule of CO2. Then when sulfur reacts with oxygen, sulfur is the green, reacts with oxygen to form sulfur dioxide. So CO2 represents carbon dioxide and SO2 represents sulfur dioxide. So these are both non-metal oxides, and we said that when they dissolve in water, they will form an acidic solution. So if we take carbon dioxide and add water, we get H2CO3, which is known as carbonic acid. And when we react sulfur dioxide, which is a non-metal oxide, with water, we get H2SO3, which is sulfuric or sulfurous oxide. So I want to go back to this table of common acids. And I want you to have a look at where we find sulfuric or sulfurous acid, nitric acid, and carbonic acid. If you look where they are found, is it possible for you to find a commonality? And that is acid rain. So when these non-metal oxides combine with water, they make acidic solutions. So what have you learned today? I would like you to take a few moments to write down 3 new things that you discovered in today's lesson. And then I would like you to write down 2 interesting facts or details that you can remember. And 1 question that you still have. And remember, if you are not able to answer that question, please email grade9@worksheetcloud.com. So grade 9s, thanks for watching this lesson, and I would like to send my most sincere thanks to WorksheetCloud for bringing this lesson to you. Goodbye, grade 9s.